Good morning, everybody. Today is Credit for Life. So I'm going to give you guys a little, video class. All right, the local politician running for re-election claims that the mean prison time for car thieves is less than the required 5 years. Okay, so we're going to do a little bit of confidence intervaling and hypothesis testing. All right, first of all, I got my sample data here. So the sample size is 80. The sample mean is 4.5. 4 years, 6 months, 6 months, half a year, 4.5. Okay, standard deviation is 1.25. Again, 1 year, 3 months, 3 months, 3 out of 12, 1/4 of a year. All right. Now I am going to calculate the standard error. The standard deviation divided by the square root of the sample size. Okay, doesn't matter that I don't have the end parenthesis, so 0.1398. Okay. Now, when I go to construct my 90% confidence interval, I will run a one sample t interval. Okay. Your calculator calls it just a t interval, but I'd like to differentiate between the 1 and 2 sample intervals. All right. So remember, stat. Slide over to test. It's number 8. Okay. I scroll down to number 8. You don't have to. You can actually push the number 8. All right. So here I put in all the data. I calculate. And there we go. Okay. So this is what it's going to look like. All right. So I'm just importing this so I don't have to go back and forth. All right. So there's the t interval. Now, you're going to be asked to do it by hand at some point. You need to know the degrees of freedom, 79, remember, n minus 1. Okay? And the critical t value, again, when we go to do our hypothesis test, okay, if we don't have a calculator that will get us the p value, we have to compare it to the critical t value. But then again, if you don't have a calculator doing that, you probably don't have the inverse t function here. So remember, second vars, inverse t, which I'm now seeing I don't have here. Great. Oh well. So backup plan number 1. All right, so here inverse t, 0.05, degrees of freedom 79. And there you go. So now remember, the t is going to be a little bit bigger than the z that we learned about in the proportions unit. Okay? Remember, basically, as the degrees of freedom increases, it will slowly approach 1.645, which was the critical z value. Again, as this thing goes to infinity, as my calculus people would say, apparently doesn't like all those zeros, so let's just leave it. Again, the limit of this approaches what the z value is, the critical z value is from the normal curve. Okay, so all right, so what we really wanted was here. All right, so negative, and technically it's negative and positive, 1.664. Okay, so t crit, the critical t value here is 1.664. Okay. Now, for our hypotheses, again, this guy is claiming, the guy running for re-election is claiming that the mu is less than 5. Okay. Which then means the null hypothesis is either that mu equals 5 or mu is greater than or equal to 5. Okay. We know it's not the second one, but either way, it doesn't matter. Since our alternative hypothesis is mu is less than 5, that means we will have a left-tailed or left-sided test. Okay, so here. That means this critical t value, negative 1.664, okay, if we get our t statistic when we do our calculations, if it's, to the left of that, that means we would reject. All right, now. And that's if you don't have the p-value. Again, if you don't have the p-value, you got to compare the t-value, the t-statistics to the t-critical. All right, now. So the conditions, the independence assumption, okay? I am going to say check, we have that because, okay, each inmate is independent of each other, okay? So what one inmate does has no bearing really on the other inmates, okay, and their prison times. Do we have a random sample? Yes, that is stated in the problem above. Okay, the it states the random 80 randomly selected inmates. Okay. Okay, now the 10%. Again, yes. 80 is less than 10% of car thieves. 10% of all. Okay, and the nearly normal condition, again, it's stated there that the data is approximately symmetric. That's good enough. Okay, so now at the alpha 0.05 level, we are going to test this politician's claim. So to do that, we're going to run a t-test. Okay, and I can do that on this calculator right here. So again, if we were doing this by hand, we would use the formula, you know, t equals the what's called 4.5 minus mu, the thing we're testing it against, 5, divided by our standard error, which, if I remember correctly, was 0.1398. Okay? So negative 0.5 divided by 0.1398 gives me that. So my t statistic is negative 3.577. Okay, and since that's to the left of our critical t-value, we're going to reject. Okay, now let's actually run the calculator t-test so you can be more convinced. So again, mu0, again, we're testing it against the number 5. Okay, our claim is that it's less than, again, the alternative hypothesis. The ha points to the left. All right, and here you go. This shows you everything here. Everything, and when I say everything, everything we need. The t-test. Let's see, here we go. Okay, now some of us need to pay attention here. So I'm going to change colors here. E-4, that is standard. That is scientific notation. That does not mean this p-value is 2.98 or whatever, or almost 3. No, that means the decimal gets shifted 4 places to the left, meaning this thing is almost into 0. So now, let's see. So what we're saying is here, again, we kind of knew we were going to reject for a few reasons. One, check out our confidence interval. What is not in our confidence interval? 5. Okay? So when we go down to do the actual t-test, again, you should have an idea of what to expect. That's why we do the confidence interval. So we're rejecting that statement right there, whichever one you wrote, which means the alternative to that statement is the ha there. Okay, so since our t statistic is less than the t critical, we will reject the null hypothesis. And remember, we talked about this yesterday. Okay? You can't just say reject the hypothesis. It's the null hypothesis, the HO. Okay? That's one way that you could write it. Okay? Number 2, since 5 is not in our confidence interval, Okay, this is not really how you should write it, but this is definitely one of the dead giveaways of why we will reject. Okay, this should be the first alarm bell going off. Since 5 is not in our confidence interval, we will reject the null hypothesis. Okay, but now the other reason why we're going to reject. Okay, since our t statistic is less than the t critical, we reject. Okay, so now our p value, which is 2.98 times 10 to the negative 4, is approximately 0, comma, which is less than the alpha level, 0.05. We reject the null hypothesis. Therefore, again, what does that mean? Now, context. Therefore, the politician Okay, so therefore the politicians claim that these car thieves serve less than the minimum 5 years is reasonable. Is it correct? We don't know, because again, it's a random sample. Now, if you want, you could actually throw in this bolded statement here. We have sufficient, again, since we rejected, we have sufficient evidence that the politicians claim that these car thieves serve less than the minimum 5 years is reasonable. Okay?